Okay,
What are we looking at here?
This is the remnants of a star that has died. The sun will have a fate such as this.
Far beyond Earth's atmosphere, in the depths of space where silence reigns and light takes millions of years to reach, the James Webb Space Telescope has once again pointed its golden mirrors toward the unknown. After years of silently drifting through the cosmos and capturing some of the most enigmatic corners of the universe, the telescope has just released a new batch of photographs, images so stunning, so astonishing, that they have captivated both scientists and the public alike. These visuals are not just scientific records, they are portals into the very nature of existence, into the origin of galaxies, the formation of stars, and the eerie glowing gas clouds that dance across interstellar voids. The photos aren't just beautiful, they're revelatory. Before we start, hit the like and subscribe buttons for more exclusive news. One of the most jaw-dropping images among the recent collection showcases a never-before-seen region at the heart of a galaxy cluster located billions of light-years from Earth. Here, amid the swirling chaos of gravitational interactions, the Webb Telescope captured massive arcs of distorted light, the signature of gravitational lensing, where the immense gravity of a foreground galaxy cluster bends and magnifies the light of galaxies hidden behind it. These arcs are not just artistic patterns, but clues, hints that allow astrophysicists to reconstruct the position, structure, and even the elemental composition of galaxies otherwise invisible. The fact that Webb can not only detect these faint glimmers, but resolve them with such fidelity, changes the way humanity can look at the early universe. Another image in the latest release zooms in on a protostar forming within a cocoon of dust and gas, a scene that had previously eluded every other observatory. Nestled in a dense nebula that lies roughly 1,400 light-years away, this infant star shines like a jewel embedded in cotton. The telescope's near-infrared capabilities penetrate through the thick veils of interstellar matter that would otherwise obscure the view. For the first time, scientists can peer directly into the birth chamber of a star, observing the spiraling accretion disk feeding material into the stellar core. The implication here is profound. Webb isn't just imaging stars, it's chronicling the very process of stellar birth in action, providing data that might help revise long-standing models of how solar systems come to be. Perhaps the most eerie image among the collection shows a portion of space so deep and so ancient that the light has traveled over 13 billion years to reach the telescope's sensors. In this field, the telescope uncovered what appear to be primordial galaxies, small, compact, red-tinted specks whose shape and brightness defy current theories. These galaxies formed just a few hundred million years after the Big Bang. And yet, their mass and complexity suggest that cosmic structures developed far faster than previously thought. The entire framework of cosmology may need to shift in response to what Webb has unveiled. The timeline of the early universe, that sacred script etched in equations and simulations, might need to be rewritten. But not all of the images are of the distant past. Some point inward, toward objects in our own galactic neighborhood. One astonishing image reveals an exoplanet in extraordinary detail, not just as a shadow transiting across a distant star, but as a world with atmosphere, temperature gradients, and spectral fingerprints of various molecules. Water vapor, methane, and carbon dioxide all appear in the analysis, and the presence of certain trace chemicals has already raised speculative whispers about the potential for habitability. For decades, the idea of directly observing the atmospheric composition of exoplanets was science fiction. With Webb, it's a regular capability. The telescope acts not just as a space observatory, but as an interstellar chemist, dissecting alien skies light-years away and bringing planetary science into a new golden age. Among the most breathtaking visuals is the wide-field image of a previously unexplored segment of the Carina Nebula. Though this region had been imaged before by the Hubble Space Telescope, Webb's powerful optics and infrared eyes revealed what was hidden in the darkness. Pillars of gas that seemed to rise like mountains into space, backlit by clusters of newly born stars. These columns of gas are not static, they are dynamic regions, evolving through the push and pull of radiation, gravity, and stellar winds. In this cosmic nursery, life as we know it begins. These aren't just scenic backdrops. They are molecular factories crafting the very building blocks of planets, life, and maybe even consciousness. One of the newer images depicts an enormous black hole at the center of a remote quasar, its gravitational influence so strong that even the surrounding light appears to spiral into oblivion. Webb didn't just capture a fuzzy blob in the void, it resolved the intricate dance of gas and dust swirling into the event horizon, offering the closest glimpse yet into the violent core of galactic evolution. The sheer scale of the energy involved, billions of suns worth of mass concentrated in a space smaller than our solar system, is hard to grasp. And yet within that violence lies creation, for it is these black holes that anchor galaxies, shaping their fate across cosmic time. What truly sets this release apart is not just the content of the images, but the clarity, resolution, and depth they represent. The difference is like viewing the universe through a fogged window and suddenly having it wiped clean. Webb has provided humanity with lenses unlike any before, peering into epochs that have remained cloaked in mystery for nearly 14 billion years. This capability is not simply a matter of advanced technology, it is a philosophical shift. Webb allows us to see not just farther but differently. Where earlier telescopes found distant smudges, Webb finds complexity. Where we once saw darkness, now we see structure. One of the photos shows a galaxy merger in such exquisite detail that astronomers can now trace the tidal tails, gas flows, and starburst activity between the colliding behemoths. These galactic collisions are not rare, but they are pivotal events that dictate the evolution of entire star systems. By studying them in real time, even if the real time is still ancient light, astronomers can better understand the fate of galaxies like our own Milky Way, which is on a slow-motion collision course with the Andromeda Galaxy. Webb gives a preview of what that cosmic encounter might look like billions of years from now. Another newly released image spotlights an ancient star cluster located at the edge of the Milky Way, previously too faint and dust-shrouded to study in detail. With Webb, astronomers can now resolve individual stars in that cluster and analyze their chemical compositions. These are some of the oldest stars in the universe, stellar fossils carrying the elemental signatures of the first generations of stars. By dissecting their spectra, researchers can begin piecing together the chemical evolution of the galaxy itself. It is like digging through the strata of a planetary surface, except instead of rocks and bones, the layers contain cosmic history encoded in starlight. A quiet but equally significant photograph comes from a deep survey of a dark region of space. While seemingly unremarkable, this area, once considered empty, is now shown to be teeming with faint ancient galaxies. This shatters the idea that vast voids exist in isolation. Even the darkest reaches are saturated with history, hiding galaxies too faint for any previous telescope to detect. This has enormous implications for the missing matter in the universe and the large-scale structure of the cosmos. It suggests that the universe is even more interconnected and crowded with life-bearing potential than previously assumed. The telescope's recent images also highlight the behavior of complex molecules in interstellar space. By capturing the spectral fingerprints of organic compounds in the dusty tendrils of distant nebulae, Webb has confirmed the presence of carbon-based molecules, the essential ingredients for life, in multiple star-forming regions. These aren't vague hints. They are precise, high-fidelity detections that suggest such molecules are not just common, but potentially ubiquitous throughout the universe. This challenges the idea that life requires extremely rare circumstances to develop. If the ingredients are everywhere, then so might be the recipe. Webb's images are not just about looking outward. They also point inward, toward questions that have haunted humanity for millennia. Where did we come from? Are we alone? What is the nature of time, matter, and energy? Every photo is an answer and a question simultaneously. Each glimpse into the abyss pulls back the curtain on cosmic processes that shape everything from galaxies to DNA. The telescope doesn't just show what is out there, it reveals what we are part of. An intricate, evolving, magnificent web of existence that spans from the subatomic to the supergalactic. A striking visual of a magnetar, a hypermagnetized neutron star formed from a supernova explosion, stands out among the recent batch. This strange, dense object, no larger than a city, emits bursts of gamma rays powerful enough to disrupt electronics on Earth if nearby. Webb's imaging capabilities now allow astronomers to observe the environment around such objects in extraordinary detail. These observations help scientists understand not just the end of a star's life, but how elements like gold and uranium are created. In these catastrophic deaths, the seeds of creation are scattered across space. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on JWST's final photos? What do you think they reveal? We want to hear from you. Thank you for watching, and see you next time.